Now, at this moment, I want to present to you Marc Deplan, who is going to be the leader of this presentation. And he's an architect solutions for Orange. Marc, please go ahead.
Okay, hello. So yes, I'm Marc Deplan from Orange. I'm the work package X leader, and I will present you the main architecture of the Pixel platform. And we will have Andrew Belsa-Pellissier from UPV that will present you other part of the project, and Ismail Torres that will present you the dashboard solution. We'll show you. So it's our third webinar. You already have two other webinars. The first one in January present you the general part of the Pixel project. And in February, we have the presentation of the build of the user stories, the model, and the algorithm that is used for the Pixel project to implement the Pixel project. You can retrieve all the webinar on the website, and you have here the link to the YouTube channel when you can show the different video of the webinar and also other video with that could be interesting. And for example, some video that presenting in detail the different architecture of the different parts of Pixel. So the organization of this webinar today, I will start with a small introduction to speak about the context of the Pixel project and why we have built the Pixel platform. And I will explain later, next, what is the main issue we have to face and how we find solution for it for the Pixel project. So the first one will be about the working with a heterogeneous data source. After that, with Andrew will present you the cross-fertilization between research projects. I will go back and present you what is the functional scalability, the issue and the solution we find, how we build the data to store and manage all the data we have. And to finish, Ismail will present you how we manage a custom visualization. So the main objective of Pixel platform, the main objective of Pixel project is to provide a solution and tools to measure, to compare, and to forecast the port environmental impact. Sorry. So to do so, we build what we have shown in the previous webinar. We have built scientific work models and scientific algorithm to calculate and estimate this environmental impact. We need but to be able to run this algorithm, we have to collect some data from the port, coming from the information system from the port and also from IoT. And we have to provide a solution to display all of this information. So that's the purpose of the Pixel platform, is to provide the tools that allow all this technical stuff to work and to be able to run the different models and scientific algorithms. Okay. So the first problem we have to face in order to build the Pixel platform is the work with the heterogeneous data source. The problem is we want the data we want to collect to do the work we have to do to evaluate the environmental impact rely on different kinds of data. We have some environmental information like air pollution, noise pollution, weather, and so on. We have information that come from the information systems that about the waste, for example, the road traffic. We have information that come about the activity of the ship, the vessel call, for example, that provides information about what kind of cargo when a cargo will arrive at the port, with which kind of cargo, what will be the operators that will manage the cargo, and so on. And we have information also, we'll see later, about the supply chain to transport all this cargo from the vessel to the output of the port. So we have a really, really huge amount of data with a lot of different data types. And one of the other problem is all of those data, all the port can provide all those data, but they have their own way to providing this kind of data. And we have a lot of different systems we have to interact with it to collect the data. Some port can provide API, we can rely to push the data on the system. Some of the port could only extract the data from the information system using, for example, CSV. Some of them have to fill the information manually in a form to put it in an information system. So we have to find a way to be able to collect all those data in all those different ways. And one of the things we have to manage is one port can provide, or for example, for the vessel call, one port can provide all the data in one time, but for other port, for the same information, we need to, they will provide the first set of information directly, and we have to make some call on other system to retrieve the other part of the data. So we have one thing we have to do for the Pixel project is to find a way to build a solution to manage all of this kind of problem. So this part is managed by the module that is called the data acquisition. The data acquisition is connected to each data source provided for the port, and is able to push the data in the information system, in the information hub, that is the main data hub, and is able to connect with the dashboard to manage all of this. And of course, as we have, as the security is an important task, the data acquisition relies on the security module to be sure that the access of the data is secure. So to build this data acquisition layer, we decided to rely on fileware. So fileware, it started on an open project in 2011. It's ready to build all the ecosystem and component and tools we can need to address smart city-like project. Fileware is now a foundation since 2016. We have a lot of, with a lot of members. It was 200 members last year, with city, industrial, startup, and so on, that is using the solution. And Fileware provide two things that is really interesting for purpose. One is a catalog of components that can be used to build the solution, and one of the most important one is the Orion Context Blocker. That is the one that we'll use to orchestrate the distribution of the data. And the other one is a catalog of smart data models that is standard, not really standard, but common data model defined by the community to address several kind of purposes. And that is one thing we'll try to address with the Pixel project. So for example, for the smart data model, the catalog addressed a lot of solution and a lot of purpose we have to see. We have data model that is dedicated to the smart city domain with the building, parking, a lot of things about transportation, about urban mobility, waste management, and so on. We have also environmental domains that is quite well addressed also. And we have for example, the cross-sector domains that come with a lot of information also useful, like performance indicator, point of interest, weather. And we also have a lot of smart data model to describe what is a device and what a lot of kind of device. But not all those domains is addressed, not all those models cover all the scope we have to address with Pixel. So to make it working, we also create our own data model with Pixel. For example, for vessel code that is not provided right now by the Fileware community. And we start to run the different pilot. We'll try to publish now all those data models, the specific data model created for Pixel, to push them to the fireware community to share it with them. So how we address clearly the data acquisition. The data acquisition is based on the fireware context blocker, that is data-driven orchestrator. Okay, it's capable to provide an API capable to collect some kind of data and manage description for the system to be able to push the data somewhere else. So, for example, each data pushed by a data source in the context blocker will be pushed in the information hub using subscription. So it's the information hub that will subscribe to any new data in the context blocker to retrieve the information. And to collect the data, we create simple part of software that is called NGSI Agent. That is each NGSI agent is dedicated to one data source and it is in charge to collect the data from the data source and to push it in the context blocker using a smart data model defined for this purpose. So the NGSI agent could manage different kinds of data source. We can manage, it could be the data source that is pushing the NGSI agent. So the NGSI agent exposes an API and the data source connects to this API to push the data in the context blocker. But you can also have the NGSI agent that is calling an API from the data source to retrieve the information. We can have a data formula web form that is pushing the data to the NGSI agent and so on. We have an easy way to create this kind of NGSI agent, and it's really useful to manage it. So when you saw now the full architecture of the Pixel platform, what we show is you have the data acquisition layer that contains all the NGSI agent that is connected to the different data source. And what is really interesting is this is the only thing that is really specific to the port. Because after, when the data arrive in Orion, we are agnostic from the data source format, and all the data are pushed in the command data model. So the data pushed in the information hub is standard from one port to another, and all the algorithm we can build to access this data and to manage this data could be developed for one port and reused directly from another if it's providing the needed data source. So this is an important part of the data acquisition. So now I will let Andrew Bellissier speak about the cross-fertilization between research projects and how the use of fireware in a maritime port could be useful to create a synergy with Dataport.
Hello, good morning. Can you hear me?
Yes.
Yes, Andrew.
And see my screen. Okay, thank you very much. Hello, my name is Andreu Belsa. I'm a researcher from the Universitat Politécnica de Valencia. First of all, thank you very much to offer me the opportunity to participate in this webinar. As you can see, I'm involved in Dataport European project. Now we are in month 18 of the project and we are providing the first technical results of the project. And in brief, this is a project aiming to provide a data platform for the connection of cognitive ports. My main role and the UPB role in Dataport is being in charge of the implementation of the Dataport platform. And more concretely, the work of the UPB is focused in the data services of that platform, like the data interoperability. Only to say that I'm going to try to adjust my presentation to the agreed time slot, but please stop me if I get over it. And now I'm not going to talk about the whole Dataport platform. I'm only focusing the synergies with Pixel and the use that we make of fireware. For that reason, if you have any questions about the whole Dataport platform, I'm going to provide my contact and you can mail to me after this meeting. With that said, I'm going to start my presentation with a bit of context of Dataport platform. And as you can see, this image reflects that in the European seaports, there are a lot of stakeholders like port authorities, shipping agents, terminal operators, freight forwarders, and a lot of interesting assets from, for example, IoT and sensors, platforms, cloud, mobile devices. But there is a lack of interoperability among the data of these systems and a lack of reliable data sharing schemes and a trusted environment. Furthermore, the ports are highly digitalized, but there are some challenges ahead. As you can see in the picture, the most important thing is that there are a lack of methods for a secure and trusted sharing of data. There are gaps in interoperability and integration and connections with other data platforms. And these are the digital port challenges. Based in that needs and that challenges appears Dataport project. And the aim of this project is to take advantage of the huge amount of data generated around the highly digitalized and connected seaports in order to connect and share the data in an easy way, provide a continuous tracking along the supply chain, or obtain a higher efficiency of processes. For example, where data coming from different sources can be combined to improve existing processes. In addition, the project is going to provide an industrial data platform, establish novel cognitive and artificial intelligence-based applications, and enable new business models. This is an overview of our aim in Dataport platform. We have, we have several instances of the platform in several stakeholders. And as you can see, for example, the data providers is the stakeholders who share data. For example, a terminal operator, a container carrier. We have the data consumers who receive and process the data, and always in a secure environment following a data governance rules. And finally, in this example, for example, the IT provider is who performs the analytics process of the port authority, but always in a secure environment. This is the overview of an example of use of our platform. As you can see, there are some logos of Dataport platforms, and the building blocks of this data platform are the following. We have the data services, we have the data governance, the data analytics, and the IDS connectors to follow the IDS rules. There are the building blocks of our platform, but you don't need to deploy all the building blocks, only the parts that you need. For example, if you are sharing data, maybe you only need the data services and the data governance, and maybe you don't need the data analytics, for example. With this context, only to say about Dataports that there are 2 use cases and 2 global use cases. It's important to highlight that we have the Thessaloniki use case as a common port in the use cases. And with the interoperability approach followed in Dataports and in Pixel, we expect to say in the following month that we can use the same data and the same agents without developing effort. The main part of this presentation are the synergy with Pixel. On the one hand, I'm going to highlight the role of eyewear. On the other hand, I'm going to explain the work during the project that came from the technical approach of the Pixel project and the potential synergies between these 2 projects. It's important to highlight that there are common partners in the 2 projects, like UPV, ProDevelop, the Thessaloniki port. This means that there has been a very active feedback between both projects, and that has favored the Dataports from the point of view of making technical decisions based in your previous experiences working with ports. The main synergy between Pixel and Dataports are these 2 components. The data access agents and the semantic interoperability broker. If we make a zoom to that picture, we obtain the following design. And we can see these 2 components interacting, the data access component and the semantic interoperability part. The data access component is who perform the agents following the same approach as Pixels. And we understand the agents as the component responsible of provide tools for the acquisition of the data coming from different stakeholders, sources, or platforms. The second part is to make them understandable for the platform users and make available for the platform users. For example, if from a data provider point of view, the agents provide to me the metadata information. For example, how will the platform get the data? If you are directly accessing to a database, if you are using an API, if you are accessing to a folder to take the data, if the data source sends the data periodically, how to gather the data, go for it, wait for it, and when to receive the data in real time, in a scheduled time, on demand, and the response if volume. The data format, if this is a JSON file, an XML, an Excel file. And finally, if there is currently semantic applied in the original data source. For example, if the data has already a data model or an ontology before the process. In addition, we have the middleware components that are composed by a semantic broker to receive information and interact with the data access layer using the normalized NGSI JSON format. We have the Dataport ontology. It's a repository with the ontology and data model description. But of course, we are not doing anything from scratch. The aim is make things usable by the ports. And we have a task in the project related with interoperability and standardization, focused into reuse existing ontologies, vocabularies, and data models. For example, in addition to the smart data models explained by Mark, we have the UNCEFAC Core Components library to cover the definitions of the terms used, the Saref ontology, or the IDS information model. In addition, we have a metadata registry in order to store the information about the available data sources. It's referred to the metadata. We have the publish subscribe component and the on-demand component. And all these components are inside an API gateway that we say the Semantic Interoperability API, who is responsible to interact with the other components of the Dataport platform, like the IDS broker, the data abstraction and virtualization component, or the artificial intelligence components of the platform. If we see the previous design from a fireware point of view, the core element of this architecture is the Orion Context Broker. Is the core of the semantic interoperability component, is who provides the publish subscribe functionalities, is who implements the metadata registry, and the data and the metadata formats are going to be designed following the fireware NGSI data models specifications. In addition, we have the data models, that is a Git repository based on the fireware data models guidelines. And finally, we have the data accents that use the PNGSI Python library. Our aim in Dataport is to provide a standardized software development kit to develop the data access agent connected to Orion, to perform the conversion to the original format, to the Orion Context Broker format, and allow and follow the fireware data models guidelines. And for that aim, we have created an internal data model. I'm not going to go deeper in detail with this image, but if I think in Pixel, you are following the same way to do the things, but we have the agents Dockerized and we have the Orion Context Broker. The metadata is shared through the Docker image description, and the agent running is who provides the data to the Orion Context Broker. Finally, in a visual way, we can say that we have different data sources. We have the data access agents, and we have a user interface to manage, stop, create, see the metadata, see the subscriptions of all the data sources connected to the Dataport platform. And here is where you can find the synergies, because we are following the same data access approach, and we are using PNGSI as Python framework to access to the data sources. Finally, to sum up, our relationship with the fireware ecosystem is a reference to achieve the data interoperability. As I said, we have the NGSI as framework to writing the NGSI agents. Our aim is to create the SDK, develop it in the context of Dataport project, and it will be improved during these 2 years in the use cases. Our aim is to follow as much as possible the NGSI LD API for the right time digital twin data exchange. This is a recommendation of a position paper of FIWARE related with the use of FIWARE in data spaces. And our aim is to migrate to use the NGSI version 2 to NGSI LD with all the changes that it implies. And as mentioned, that there are 3 brokers to implement this linked data format of Orion data, and we are going to use Orion LD broker. Finally, as Mark says, we are very interested in being aligned with the Smart Data Models Initiative for description of data models. And as happened in Pixels, now we are working in internal project repositories, but our aim is to contribute to the Smart Data Models Initiative, and our aim is to create a smart ports repository. And finally, the aim of the project is be totally aligned with the Connecting Europe Facility digital program in order to be aligned with the European Commission. Finally, this synergy offers to Pixel the Dataport opportunities. And without more details, these opportunities are a semantic approach for data sharing, a trust and security in data sharing, a data trading using blockchain, and novel cognitive and artificial intelligence-based services. And in addition, to integrate the data of Pixel in the industrial data spaces approach. And yes, this is all from my side. I don't know if after this presentation you have any question, but thank you again for the opportunity to participate in this webinar.
Thank you, Andreu. I think we will wait for the... I see that Nacho already has a question. Nacho, if you would like to ask now, please go ahead.
Yes, hello, I don't know if I am heard. Hello.
Yes, hello? We can hear you.
Okay, great. Well, first of all, thank you, Leonidas, for organizing this webinar once again. And thank you also, Mark, for the presentation, and Andreu as technical speaker. Thank you for being here and presenting your nice project and your synergies with Pixel. I had one question, because I have realized that the influence of Pixel, it's clearly seeable in Dataport, as you have mentioned, and I believe it's a very good project. But I would like to know whether, aside of the technical part, if there have been any collaboration between Dataports and Pixel through some CSA or some dissemination events or something.
Hello, Nacho. Thanks for the question. Yes, in addition to this technical contribution, we are working, for example, now in papers, more related with position papers, in order to find some synergies and put in scientific documentation. And for example, last year, we write a paper together with Pixel called Framework and Methodology for Establishing Port Policies Based on Real-Time Composite Indicators and IoT. And it explains the possible synergies that I provide today in an interesting scientific publication. But now we are trying to include this approach of industrial data spaces in more publications in order to provide this point of view and providing the documentation, these synergies with Pixel and Dataport. For example, the approach of industrial data spaces, the use of blockchain, all these things that Dataport can provide to Pixel, and the data that Pixel can provide to Dataport.
Thank you very much. This is great.
And of course, we are open to any dissemination contribution, collaboration, or participation in common events. For example, Carlos participated in an event of the BDVA, the Big Data Value Association, presenting Pixel together with other projects. and this webinar was promoted by Dataport.
In that sense, thank you very much, Andreu, for that. In that sense, I would like to take advantage of this opportunity to say that we will be having a final closure dissemination event party at September, the month that the project ends. So, of course, I would like to extend the invitation to you and all the members of Dataport for joining us on that event.
Thank you very much, Nacho, and totally agree with that.
Thank you, Andreu, very much. Mark, you can continue with your part of the presentation.
Okay, I will try to run a bit quickly. Just a point about PNGSI and NGSI LD. We're working right now on our own side to make it compatible with NGSI LD, and it will do. I think a new version of PNGSI supporting NGSI LD will be available around September, because we have some stuff, a lot of things to do. But if it's interesting you will have the new version quickly. So the next part of the presentation is about the functional scalability. One thing you can see in the fiber architecture, in the pixel architecture, is that the idea is we can connect a lot of kind of data source to collect data from the port, and we want to run a different kind of algorithm and scientific models and KPI calculation and so on, coming from different sources of scientific source. So the idea is we need on the platform, when we build a platform, we need a solution to be able to extend the functionality of the platform, connecting an easy way to connect new data source, an easy way to deploy new models on the system, and we need to be able to manage this through an API, because what we want is that from the dashboard, the operator could modify the configuration of the platform to add new capability and new functionality. In order to do so, exactly like Andrew said about Dataport, we decide to rely on Docker, because Docker offers a lot of functionality and capabilities that is really interesting for this kind of problem. It's now it's state of the art for software delivering. We can, when we use Docker offers several ways to manage runtime configuration. So you can build an image of a container that is able to be configured to be deployed in a specific infrastructure that is quite easy. You can use environmental variable, you can use label, you can use configuration file, and so on. So there's a lot of ways to configure a Docker container. So it's really nice. You have also all the mechanisms from the registry that is available. So you can push the image on a registry. It could be an official registry like the Docker Hub, or a specific one for your project. And then it's easy for the server that is running the Docker to download the image from the registry and to deploy it in the software. So it's really, really nice. And it's also what is a thing that is really good for the developing of the model and the NGSI agent. Interacting with Docker, you're fully agnostic of the development language. So you can develop for example, you can develop the NGSI agent in the language you want. We provide with Pixel, and that is used in Dataport. We provide PNGSI that allow you to quickly develop an NGSI agent using Python, but you can use .NET, you can use JavaScript with Node.js feature, you can do Java, you can do whatever you want. And as long as you package it using Docker and following the good specification for the deployment, we can run the agent of the platform without any problem. So it's really nice. And of course, the Docker engine provides an API that allows to dynamically manage all the features of Docker. So you can deploy a new component using an API. You can run it, stop it, check its status, and so on. So it's really nice. So to do so, we we create some kind of specification for the for our Docker container for NGSI agent and model an algorithm in order to be able to allow this container to interact with the Pixel platform. So we define how the container should be configured and should take the configuration information in order to be able to run in the Pixel platform. So you have on the YouTube channel, you have a full video that describes how to, for example, how to build an NGSI agent or how to create a new model. We have to find a way to schedule the execution because it's we have to provide solution for the to be able to run, for example, an NGSI agent every hour or to run a model every day or every week. And we need for the dashboard to provide information to monitor and access to the logs of the different containers, especially if, for example, for the model to be able to show the status and of the run and if there is any issue. So to do so, we have built two orchestrators that is managing the specific feature. One is for the data acquisition, that is managing the agent creation. It's managing the connection with the information hub. So we have to provide several information in order to allow information hub to collect the data provided by the NGSI agent. So the orchestrator is also able to schedule the run of the NGSI agent. And as some of our NGSI agent expose API, it also provides a way to expose the API of the different container of the NGSI agent to the external access through the security layer. And and also it provides information to connect the NGSI agent to Oreo. And of course, it provides an API to manage everything. The other orchestrator we have built using that way is the operational tools. The operational tools is in charge of the model and the scientific algorithm. It manages the way to configure this model and in order to access the information hub, in order to collecting the data from the Pixel platform. He manages the schedule of the model and creation, and of course, he provides also an API to allow to do all of this through an API. So that's it for the orchestration. And the next problem we have to face on the Pixel problem, as the Pixel platform, is the data. The data hub is one thing you have to understand is data hub is quite easy. Could seem functionally is quite easy, but it's not. In fact, it's not really easy. Not really simple. Data hub is a way to connect to store all the data we need to manage by the platform. But when you check the real functionality we did for the data hub, it's really more than just a database. For the problem we have to face in Pixel, for example, we need to be able to store heterogeneous data. So we want to be able to collect new kind of data with new data type and so on, with a completely different kind of data. We need to be able, for the need of the model, we need to be able to manage long and short-term history of the data. So we need to be able to run statistics about how the data change during the time. As the amount of data could be really huge, we did a system that is capable to be scalable and to be able to manage all this amount of data, but and to adapt to the amount of data. As some data source will push quickly a lot of data, we need a system that is able to store the burst of data. And because for the need of the different algorithm, we need a way to provide a solution to run complex query on all this system. To do so, we have relied on one of the experience of one of our partners, that is XLab, that has built kind of similar issue for a big project like is the FAIR experience. So the FAIR is a facility for anti-proton and ion research. It's a particle accelerator in Germany. And XLab have built a complete system to collect the data and managing all the historical information to run the diagnostic of the status of this accelerator. So they have a full experience in this, and we have decided to rely on their experience to build our own data. So as you can see, the information hub is a lot more complex than just a database. All the storage is done using Elasticsearch, so for the short term that is managing the short term and the long term story. But as you can see on the schema, you have a lot of other components. You have a data blocker based on Kafka that is managing the orchestrating the different events with the different partners, with the different components. You have a component that is collecting the data from the data source here, for example, in Pixel. We have component that is in charge of writing the data in the different storage to reduce the data in the different storage and so on. You have component to manage all the cluster that could be run to adapt to this capability. And you have also functionality to extract data from the storage and to be able to provide the data that is needed by the different model and so on. So it's a very complex solution that is very, very useful for the Pixel project because collecting the data is important. Building the model and so on is important too. But if you don't have a way to store and access the data, excuse me, a good way to access the data is exactly like you have no data, in fact. So, well, the solution provided by XLab is really, really, really useful for it. And the next and the last part of the presentation will be about the visualization of data in Pixel. And I will let Ismail Torres present you what we have done on the visualization.
Okay, Mark, thank you for your presentation. Let's continue. Can you hear me?
Yes, we can hear you very well.
Yes.
Okay,
Yes,
so let's move to the last point of the presentation, and now I'm going to present the visualization data in Pixel, how we develop this part. So the idea is to talk about the strategy that we have been using for defining these visualization mechanisms. Okay, and this is where some research and development projects fails because they think in prototypes, and we try to think in a possible product to be usable in the end of the project. So for that reason, before starting the development of the visualization or dashboard, we try to address these questions before: how we are going to represent the data, who will be in charge of using these visualizations, and is it needed to have technological skills to create these visualizations, and which technology we are going to use, and finally, how we are going to leave this platform open to be scalable in the future to provide support for new visualizations and new models. So these are the questions that we solve before developing the platform, and for sure during the project we change our mind and we do a lot of changes inside because we always have in mind to provide value for final users. So this was our main focus, to provide an end-usable visualization platform for users. So First of all, the first question is how we want to represent the data, which information it's interesting to show in the platform. And in the end, we agreed on having several visualizations parts in our platform. First of all, it's to provide dashboards on graph for showing the data coming from models. The second is to provide a mechanism for notifications and alert system, because this is a real-time system and it's very important in this type of systems to provide this type of mechanisms. The third one is to provide a report facility for generating the different reports needed in ports. And the last point is to use maps, because some of the information that we are retrieving are coming from sensors, and these sensors are in a specific part of the ports, and it's important to have this view in the platform. So these are the information that we want to represent. The second question is relating of who is going to create and use the visualizations. We are going to let the end user, that it's the port staff, not technical, to create the visualizations, or we are going to use to need the IT crowd, okay, or the technicians to create visualizations. So this is one important question, because it depending on the solution, I think that let me say, it affects us how we are going to deploy the platform and how the visualizations are going to be created. So the third one is, are technological skills needed? So for creating visualizations, some frameworks can create visualizations using JSON data or XML data. In the left side, you can see how we can create visualizations using some libraries. This is a JSON file that you need to provide to create a visualizations. Or in the right-hand side, you can see that we can use simple wizards or assistants for creating visualizations, several steps where the user start focusing on different models, different type of visualizations, and different parameters. So, which is our position? In this case, we prefer to use wizards instead of using JSON or this type of formats that are commonly used for creating visualizations. The third one is which technology we should use. So for creating visualizations in a lot of platforms, you can use business intelligence tools, but in this case, some technical skills are needed. Okay, and you need to know, the most important thing is that you need to know all the models that you have in your platform. You need to know the objective of these models and which data they are storing to prepare the visualization. So for creating visualizations, you need to know which data you have. So you need some type of skills. And one of the most important problems here is that these technologies, a few years ago, they were free, but nowadays they have a license that it's not cheap, and in our project we are providing open source technology. So we are not close to pay solutions, because if they are good, we can integrate, because at some point you will see later that we can integrate these technologies by using iframes, but in principle this is a limitation for us. Okay. The second option was to use dashboards based on Kibana and Grafana that are more focused on time series data. Okay, but in this case, you need to have high technical skills. Okay, to develop these nice dashboards, and also again you will need to know the models, the output of the models, and how you can visualize this information in a proper way to provide value for customers. And the third one, that is the solution that we use, is that, okay, if we want to provide an easy solution without not needed skills, so we think that using a JavaScript framework, a free JavaScript framework. For instance, we are using eCharts, but there are a lot of JavaScript frameworks for creating visualizations. So you can use whatever you want. Okay, and in this case, you need for sure you need to have knowledge to create visualizations, because this in the end, this use JSON information for creating the visualizations, but for that reason, to avoid this complexity, we created another layer that is the wizard layer. That in using this wizard, we avoid to know this to know in the inside part of this library. So using these wizards, you will able to create visualizations very easy. Okay, and the integration. So we are using the same technology that we are developing for the all dashboard. So the integration is very easy and it's well integrated. And using the previous solutions, you need to use iframes and the integration is not so easy. So to finalize this and the last part of my presentation is okay. If we want to be extensible enough and if we want to provide new functionality, because the platform, as Mark said, it's extensible. You can install any intelligent model that you want. And in the future, when we finalize the project, if you want to add more functionality, it's pretty easy. If you create your models using Docker, so you can provide this functionality. And the intention to avoid the complexity, we define this type of wizards. Okay, so every time that you want to include a new model, this model should come with this wizard. So when you provide a new functionality, a new model, you should provide the model itself and the visualizations of the model. So as a model provider, you know which is the best way to represent your data to provide value. So for that reason, you provide the model and you provide the visualization of this model. And this visualization, it's integrated in a framework that we have developed in Pixel. Okay, so you don't need any technical skills to create visualizations because you have a steps, a wizard with several steps that guides you to create these visualizations. And now you have some examples of how the visualizations look like. In this case, you have 5 visualizations. In the first one, you see a Gantt diagram with the vessel calls, with the vessels that are arriving to the port in the next days. In the second figure, you have a map with a heat map with the dispersion model of the noise in the port, taking into account the vessels and the activity that you have in the port. The third one is a graph visualization with the prediction of the congestion in the future. Okay, so we have a predictive model that calculates the congestion outside the port or in several points or areas that you are interested. Each port can define the areas that they want to monitor. So we calculate this visualization. And the last 2 visualizations are related with the pay and shows the evolution of the environmental performance indicator that we have been developing in the port. And you have a graph and you have also a gauge with the final value. So that's all for my side. I'll be very short because we don't have many time. Okay.
Thank you very much, Ismail. This was the presentation. Now, welcome everyone who has a question to go ahead and ask the presenters. I see that Nacho already has one question. Nacho, please go ahead.
Yes, thank you, Leonidas. Thank you, Mark and Ismail, for your nice presentations. It was pretty enlightening. I have one question for Mark, because I am see that you have explained some kind of data hub, long-term storage database that has been developed specifically, well, designed and developed specifically for Pixel. I would like to know why you have not used some fireware enablers to cover that part, because I know the STH, for example, or Cygnus enablers from fireware could have done the work. I am curious because I am seeing fireware very present in the architecture, but not in the data hub. Why is that?
Why is that? Because in fact, fireware provide several enablers to store data. For example, you have so to store historization, you have Comet, for example. You have a new component that is not completely new, that is arrived a few years ago. That is a quantum lead that provide time-series database to manage the data. But what we want to store in Pixel is more complex than just a time series element. We want something that is bigger. So what is the most, the thing that is could be the most important, the better enablers that we can use from firmware is the one that is built on top of Hadoop, but it's not exactly what we want here. And the solution that provides XLab is really better for what we want. And in fact, in firmware, firmware is not providing all the solution to do everything, and it's a normal architecture in firmware to push the data in the different in the data you want to manage the better thing, how to manage the better the data for your needs, for the special needs. So that's it. And with solution provided by XLab, we really have a solution that is really fit what your needs for the Pixel project. And the generic enabler from firmware is not as good as the solution of XLab for this.
Well, very good. It's clear. Thank you, Mark.
Thank you very much. Since we are running out of time, if we have no other questions, I would like to thank Marc Desplandes and Ismael Torres. And I would like to also extend special thanks to Mr. Andreu Pelsa, who is an external speaker from the Pixel project. And I also would like to inform all of you that the next webinar, which is going to be presenting some things regarding the Port Environmental Index, is going to take place in early July. See you all then. Thank you very much.
Thank you all.
Thank you. Bye.
Thank you. Congratulations for the webinar. Bye-bye.
Thank you. Bye.